Hello, welcome back to the basement. We're going to start. So today we're going to go in and try to finally tackle this quick emulator. We're going to start off by just following exactly some of the guidelines we've seen online, some of the tutorials. We're going to do exactly theirs, which uses the uh, the machine was like virtual PB or something like that, and it was not quite an M4. It was a different Cortex, and we're gonna this time put our project under um, in a way that it shares it to our host machine, so we never lose anything, and I'll be able to push that code. So let me switch over to coding, and we can just start. No reason to waste time. Let me make sure that the audio is working properly. So, I don't need that. So some of the links I had open still. Let me find the one that we need from. It's not this, not that. Let's say it's this one. Now I know I have it open. I think maybe it's this one. Yes, but this is his other page. I think we want. Is it this one? Yes. Yeah, it's this one. Okay, so we're gonna follow this. So I have my. Let me make sure this is big enough. I have my terminal on the left, and we're gonna follow his notes. So we're gonna just take his exact application, and we will let's make a directory for our source. CD to source. And what's great is we can edit this on our host machine as well. So if we want to, we can open up Notepad++. And if it went off the screen, let's change folders. Open folder. Is it this? Open folder as workspace. And this is under, I think, it should be under there, streaming. Is it gonna do it? What is? I know a lot of people use Notepad++. I don't get it. Seems pretty weak. Let me try it again. Folder as workspace. Windows is fun. Oh, I already have it open, that's why. Alright. It was my fault. Yeah, so we're going to make a new source file. Let's just copy all the sources we need. So he has this code right here. He calls it test.c. We're just going to literally just get his working so we can do the end-to-end and prove that everything works the way we expect it to. So test.c. And I think that just put it in the wrong folder. It did. And you can't drag and drop. Are you serious? What kind of UI is this? Alright, open Explorer. Wow. I'm so used to Mac now, and I barely ever use anything else. Alright, cut paste. Yeah, something Mac can't do at least. Keep this file in editor. No. Close that one. Open that one. Alright, so we have test.c. Now what are the other ones we need? We have a linker file, a linker script, I mean. So this one, and I think there's a few that aren't in this that he references that from his other projects. So the linker script We could also just put it in here. So let's do a new file. Always end with a new line in case. Come on. Yeah, source. What do they call this? Startup.s. This is the startup assembly. Startup.s. Okay. Alright, startup.s is there. Now they want test.ld for the linker script. Control N. Paste. New line at the end. Test.ld. And we can leave the script in there. Alright, let's read it from top down, make sure we didn't miss anything. So he talks about last time he wrote, so we might have to go there for some extra details. I never did fully confirm that my audio is working. Let me do that. Yep, it is. Okay, great. All right, so last time I wrote about writing and debugging bare metal ARM software using code sorcery toolchain. I want to explore the quick emulation of a complete system and create the simple hello world example. The quick emulator, let's see where he links to. Is it? Okay, so this is like their wiki from QEmulator.org. And we'll learn more about that. Supports the versatile, it wasn't virtual, it's versatile, PB platform that contains the ARM 926 EJS core. And among other peripherals, 4 UART serial ports. The first serial port is in particular UART 0, works as, my screen cut out, as a terminal when using the no graphic or serial to standard I/O. Quick emulator option. The memory map of the versatile PB board is implemented in Quick Emulator in this board specific C source. It doesn't exist anymore. What did the link look like? SavannahGNU.org. Versatile PB. We could probably look for versatile PB.c. So what is this guy? We might need him. What is he referencing him about? I went to the wrong one? No. The memory map for the board is implemented in this C file, so it's probably that one. From that I note that the address where the UART is mapped is this. So let's actually look that address is in this one, and we might actually need to clone this repo. So serial HD, yeah, it's UART 0. One second. Gotta turn on my heater. Being in the basement could be cold. So this has a lot of stuff on here, but there, you can see there's the 3 UARTs. He said there was 4. Maybe the SPY counts as 1. I'm gonna hit the one we're caring about all the way to the end. Makes it easy to find again. All right, thank you. Okay, so the code that emulates the serial port. So he said there was 4, right? My screen keeps blinking because I have a weak graphics card I need to upgrade. 4, but I only see 3. Maybe he's counting this SPY port. So what type of things are in this code? Let's see what functions. Is there a header file that goes with this? Is there maybe a and so this is this the full source code for the quick emulator? Oh, there's a lot here. All right, GitHub. How do I search you? Search this repo. Search or jump to? Well, there's a little. Am I nuts? Oh, I should have just looked at the includes that would be declarations for the functions they're going to define here. What I wanted to see is just everything that they're going to expose through header files, but it looks like it might be spread out. GPL. OS dependencies, I don't know. Errors, CPU, bus, VM state, PCI, I2C, interrupt IRQs, request handlers, hardware boards.h, that I want to look at. Address spaces, that would be interesting. Flash. So let's go to hardware. Let's go to the hardware folder and look at the header files, and let's. I don't want to get too sidetracked, but so that's 2 up. So boards.h and maybe blocks and then flash. Wait, what? Oh. Wait, what? They must have an include folder somewhere. Where's that at? Boards.h. Is there a readme with this guy? Let's see. It's a generic open source machine and user space emulator and virtualizer. Quick emulator is capable of emulating a complete machine and software. So this is if we're going to build it from scratch, though. Submitting patches. Do they have an include folder? I mean, this is where we just were, but we didn't have. There was no hardware.h. I feel like I should just be able to put hardware.h and it would be like, here's hardware.h. Which is like searching in the files. I want to search for a file. I'm also want to git commit. Go to master. Oh, here's include. And now there should be a HW. Okay, there you go. I was just passing over include over and over and over. That was... maybe I need more coffee. Mem, MIPS. So we wanted to look for hardware.h. It should be in here. HW.h. So config user only. If you define that, cannot include this header then. So that prevents that. Else it does a hardware. It defines just a prototype or declaration of this function. So it doesn't do much. I'm gonna go back to that. Let me keep this open in that window. Go back to we want to stay on master, but we want to go back into hardware, HW. Wait, what folder am I in right now? I'm already in hardware. Alright, where's that virtual? versatile PB. I thought that was in here. Going in circles. Versatile PB. Hardware ARM. Oh, okay. Alright. So let's see. Oh, there's boards.h. Maybe they change it because I don't see HW anymore. I need to be on master branch on both of them. Alright, so let's go to, instead of, what was it? I'm already forgetting. Boards for days. Alright, so here you go. Now you're talking about stuff with like CPU and all that, and they're gonna have a lot of like if this is defined and if that and all that. So they're gonna declare some. Let's see. So some suffix, that's fine. They're gonna define a machine type name, and they take the suffix and what they're just putting. I thought you concatenate differently. I thought there was like a double % or something to concatenate. Machine class name that needs to be started with class name based machine lookup. Because I'm pretty sure they're trying to make a very. I'm not following this macro. I don't know why. You would call this passing in a name, and then you have the name equals this. I'm missing something. Such a simple macro. Why I'm not seeing it? But you wouldn't want just machine name equals dash machine. Like you would want it to be the suffix appended to machine name. Oh, it is doing that. Oh, and you call this, yeah. I'm just slow today. Alright, the undefined machine. Define machine as a function that takes an object. Object check machine state. So they're doing a bunch of stuff. They extern the machine state. There's a whole bunch of details here that I don't really care about. But I wanted to know if there was like initializations and stuff that needed to happen. So machine class. I'm definitely off track. Off what's it called? Topic. Alright, so that's interesting stuff. But here's the versatile.c that he's talking about. It's going to define a bunch of stuff, and we saw. Let's see, make sure that the UART port's still here. So that was this address right here, and let's see if it's still defined in here. Saw it here. See that in this comment it talks about it. We should go to the memory map. That's really what I was like looking for the other day. Is like how do I tell how things are mapped? And right here it's just telling me in a comment, but there needs to be some defines to it. Well, actually, maybe there aren't because they're just using the addresses here. But you think that you would use like names and stuff so you can remap it. It's kind of weak. And I wonder what are they doing here. Need a new HDMI cable. Is this like some initialization? So in a knit, we might see them pop some stuff. Well, they create at that address some type of display device. So this is all like the startup of the actual machine. So this is how they write the versatile PB machine for the quick emulator. And that's why they're talking about, okay. So let's go back to the code. I think I learned a little bit there, and we know now where we can dive in deeper. So the memory map for the versatile PB board is implemented in that. Okay, so yeah, from that I note the address, so we can actually go look up addresses for other peripherals. So that's going to be good now, so we can reverse engineer it and stuff. Um, the code that emulates the serial port inside the quick emulator. Here is the source repository. Watch, it's going to point me. Oh, no, it's broke. So they used to have it here, then they moved it to GitHub. It looks like they were like, "We love Microsoft." They bought GitHub. Nobody said that. Nobody. Um, Implement a subset of the functionalities of the PL011 prime cell UART from ARM. I'm sure that's something that I should know, but I don't. There is a useful technical manual from the ARM Info Center that describes how to interact with the hardware. Let's see if this link is broken. Oh, temporarily unavailable. Let me guess, it's never available. What? What? What are you doing to me? Let me see where this. What does this link say at the bottom? You chat probably can't read it, but it's infocenter.arm.com, help topic, com.arm.doc. Some numbers. So let me see what, when I searched for that, was that the same one? Yeah, I think it was. I think that's actually the same one. I could probably go to the, is it 0183F? 0183. Yeah, let's go to the cache version. Google's pretty good. Cache like some old PDF. Probably like scraping off a platter drive in a basement at Google's servers. Alright, but this is just to talk about how their UART varies from standard UARTs by the technical little details. I think that's what it was saying. A subset of the functionalities of the prime cell UART from ARM. I don't know the details on that. But there is that here. We have it now. I'll move it down here just so it's. But we have it. If we need to go look up something funky is going on. In details, there is a register, UART data register, that is used to transmit. When writing in the register and receiving, when reading bytes, this register is placed at offset 0. Offset 0 to what? To this? Oh, yeah. So I need to read and write at the beginning of the memory allocated at UART 0. To implement this simple hello world print, we do this. So it does a while loop, and it keeps walking through the string. Where's it advance? Oh, it advances this pointer, and it keeps walking until it gets a null terminator. So make sure you pass in null terminated strings, and they do right here, with a new line at the end. All right, so we have the code there. I don't think we need that .c because we're not referencing any variables. So let's assume we don't. The code is pretty straightforward in a couple of details. The volatile keyword is necessary, yeah. Oh, volatile on this? But it's constant. Wait, what? Oh, because it's going to be to instruct the compiler that the memory pointed to by. Oh, okay. Oh, the thing you're pointing at is volatile. Yeah. The pointer doesn't move though. So the volatile keyword is necessary because it's pointing at stuff that can be changed independently from the program, because the emulator can be changing it while you're referencing it. The unsigned int type enforces 32-bit read-write access. Okay. That's on the actual pointer. Okay. The quick emulator model of the serial port ignores the transmit FIFO capabilities. In a real system on SOC, the transmit FIFO full flag must be checked in the UART function register or FR register before writing to the data register. Yeah, so you would wait for it to be cleared, and then keep writing until it's all out. The quick emulator is written especially to emulate Linux guest systems. For this reason, its startup procedure is implemented specifically. The dash kernel option loads a binary file, usually a Linux kernel, like your actual Linux OS, inside the system memory starting at address 10,000 hex. The emulator starts the execution at address 0, where few instructions already in place are used to jump at the beginning of the kernel image. The interrupt table of ARM cores, usually placed at address 0, is not present, and the peripheral interrupts are disabled at startup, as needed to boot the Linux kernel. Knowing this, to implement a working emulation, I need to consider a few things. The software must be compiled and linked to be placed somewhere not at 0. I need to create a binary image of our program. Well, yeah, it has to be. Yeah, it has to be runnable. I can ignore interrupt handling for now, but he will make startup code and put the startup subroutine. Well, it's not really subroutine because it's not. Yeah, it's not. It's just code. He puts the reset. He puts that at 1,000. The only thing I don't see is what causes it to go to 10,000 hex. He said something about that, but the emulator starts the execution at 0, where few instructions already in place are used to jump at the beginning of the kernel image. So is it saying I don't have to do that part? But wouldn't my binary image have to have something at 0 that's going to cause it to jump to this? Or maybe it's a little weird. I'm going to look for this address in their code. See what if we can that's not it. It's RAM size though, we might need that. Well, there's system registers. Oh, I found a UART3. It's just that it's not with the other UARTs. There's GPIOs too. That's cool. So we didn't see anything, right? Ethernet. It might be a tab though. Alright. Let's just try it and assume that he knows what he's talking about. But I don't really see how our binary is going to have something that's going to go from 0 to 10,000 hex. Right? Because reset is being is in startup, and that code is going to be at this address. Because it's going to move the current address to that, and then it's going to say startup is startup.o goes to startup. Text data, BSS common, aligned at 8. And then they put the stock at the top of the stack 4K away, like from the end of the program. To create the binary file, must be installed and put in your path. So we should have that already. Cool. So to make it simple, we're gonna make our build script out here. trying to decide. Let's just put the scripts right in the root directory. Let's make new scripts. So this is going to be a bash script. And what we're going to do is start off by let's just take all of his commands. Does this have block select? Oh, it does. Cool. If you don't know about blocks select, I'm going to change your life. I look for it in every editor I use. In this one, like a lot of them, if you hold down Alt, you can select a group. What's great about it is, like, if I wanted to insert something in the middle of this, I would do some like trickery where I just do like replace all spaces with like a few tabs, and then I would just do like replace all. Didn't have regular expressions on. Hold on. I go bam, and then I can like block select right here, and I could be like, all right, I'm gonna add in here some like flag like -G. I'm gonna turn on debug. It's already on in the other ones. And then what I would probably do is I'd be like, all right, now I need to get rid of all those tabs. So I'd just be like, replace tabs back with a space, and then just do bam. And then I would take double spaces and replace it with a single space, and just do it until there's no double spaces left. And now I got that in there. So like little tricks like that are like super helpful. Or if like say all the arms were typoed, I can just be like, let me just go like that and just do it's arm now or arm. It's like the greatest. Like little tricks to make text editing easier. It makes you so much faster and you're not wasting time. All right, so we want to put a build sh, build sh, shabam. All right, so chmod that for +x. A lot of people use like the nibble form, like 777 and stuff. Use the letters, like they're so much easier. The only time I'll do 777 or something like that is when I want to just jump to one of those key ones that are, it's like super fast, or like 600 for RSA keys, or like there's like ones you just know. But a lot of times, if you just want to be like, the group gets privileged for execution or read or rewrite, or you can do like group or user or what's the other one? Is it group? It's everyone. It's user, group, everybody, right? Like global or whatever. User group and then all. Whatever. So I would just like chmod +x, or I could just do u+x for just doing the user on my build sh, and it's already executable. I don't know how, but okay. It's like everything gets automatically. Even when I made it on my host machine, it came in here, so it was already executable. Really weird. Well, let's try to build. It's probably going to say a bunch of errors. And Windows, DOS to Unix, I need to make Notepad++ use line or new lines and not carriage between line feeds. Let's just do that. Ugh. I feel like it's such a small application. Why isn't it just installed on every machine? DOS to Unix. All right, now let's try to run it. Seriously? Oh, okay. No, it's trying to run. Okay, so what happened? Assembler message, can't find... Okay, so that's because my paths to files are not correct. What? Oh, yeah, reload. It's in the source directory, so I'll just make a variable here. It's like source equals source. Don't want a trailing one because I'll get doubles. So I'm probably going to want to make like a target. Let's just make one. targeter equals target. Cool. And the output files, we're going to want to go into a targeter. Sometimes I'll like pause for a second because my screen will literally flicker. It's so annoying. You guys don't see it, but I think I have a bad DisplayPort cable, or the port on my graphics card. I'm just about to buy a new one of both because my graphics card's 5 years old, and I mean it's a Fury, but it's like not great, and it was good at the time. I just haven't built my computer in 5-6 years, and the cable is cheap. I'll probably do that and just see if it fixes it. But at some point, I want to get a second machine and dual computer streaming thing, because it's way easier. Because then I can manage my stream and program, and you don't see any of my passwords or anything that's going on. I worry like I'm going to show something. And it also, I can restart my programming machine and my stream doesn't go down if I need to install something. Part of why I use a VM too is so that I can restart it if I need to. So I'm just putting paths to all these, and they're gonna make a binary. So let's just break down these statements. So they're gonna run, instead of running GCC and telling it which program to run under the covers, because that's usually what happens when it's going to do all these things for you, and you're telling it like run the assembler. I mean, like GCC is going to be like, oh, I know I need to run the AS command because they've broken them out into separate programs. And if we go to the bin folder, and so we know from our other weeks of working, we installed it in user local bin, and we added all the paths and everything. But in the bin folder, you can see all the executables that are here. And when you run GCC and you're saying to run the assembler, it's really just kicking off the AS guy. And if we want to, he's in the path. So, oh yeah, I forgot I can't copy paste. Still got to get a better terminal. I hate Windows. Like, I just got to get. It's not that I hate Windows. It's just I'm not like current on it. So you can see, and here's all the assembler options. And so he's setting the CPU. That should be somewhere on here. MCPU name right here. G, we know that's for the debug information. So that allows you to hook GDB to it and everything. It has the symbols, and so like you can it'll link to code properly if you have like an AXF file, or in this case, what do they make, like an ELF file? Same thing. It's going to link it into with the symbols in it. So they're going to compile this source file, which is an assembly file, and they're going to have an object file spit out. Then they're going to compile C code, which is going to do the assembly. It's actually going to do the preprocessor compiling and assembly, I think. And then they're going to do the linking separately. Yeah, because they're doing -C. What was to just do compiling but not assembler? The assembler. I forget. S? I want to say it's. I want to memorize it. Is why I kind of want to just go and just look real quick. What? Oh. That's funny. The one has it as -help for the assembler, but for GCC it's -help. Okay. It's capital S. Yeah. Little c does the compile and assemble. Capital S does compile only but doesn't assemble, and capital E does just the preprocessor. Yeah, so we're going preprocessor compile assemble with -C, where this one is just doing it doesn't need to do the preprocessor because it's lowercase s. If it's capital S, it would tell the assembler, oh, I got to run the preprocessor. But because we're kicking off this guy directly and not GCC, it doesn't need to go and be like, oh, I need to kick off the assembler. It is the assembler. And I could be a little off on some of this, but that's how I interpret it. That's what I. So let's look at the linker and see what -T does. So arm LD. Watch. Okay, so that one's -S help too. Dash capital T. Oh, it's the script itself. So yeah, and I thought there was a we have a full path to it. There was a way to say like where to look for linker scripts, and then you could just put the file, and then it's going to look in all those folders. I forget. I saw it on another example before. Maybe it's path. No, I don't remember it being Y. That's Solaris. Is it -L like add directory to the library? No, that's library search path. I thought it was like little L. No, these are all libraries to link to, like the directory and the library. But there was definitely a linker script. I'm probably staring at it right now, but I just don't see it. Yeah, you can also after the fact strip the symbols out. I've had to do that before, mostly for caring about space and size. And you're like, actually, what did I do? I compiled. This is something I did a long time ago at work. We compile all of our stuff with symbols, and then I stripped the symbols out. And because we were using GDB server on a remote host, and we needed the symbols on both sides, and we were going to old binaries that before we were ready, because you can generate the symbols separately from the beginning and the binaries, but you need when you're connecting to a GDB server, you need the symbols on your client side as well. It was pretty cool, and we got it to work, and because we're doing embedded systems and stuff, and you can have the GDB server running with the code on the device. Actually, I think the device doesn't even need the symbols. I think only the client does. I think that's part of why it was so cool, because then the binaries are small and the normal size you would want them to be, and it's more realistic on how it's actually going to run, and you can take pretty much your releasable binaries and then have the symbols for them and be able to debug into them. Yeah, it was something like that. I mean, this was like 3 years ago, so all right. I think we still do that, by the way. I don't work on those teams anymore. But let's see if this all runs. So we saw the T that says the linker script. Here's a source file. There's another input file, and then the out file is that ELF file. And then the last is we do an object copy, which converts the ELF file into a binary. And the dash cap. My monitor's display just went crazy. What the heck just happened? Let me just tap the wire. Oh, that fixed it. Yeah, that's not good. Yeah, this tells it the output format, and we saw that there was iHex for Intel hex and some of the other formats, but binary is what we're going to want to say we're like a kernel binary for when we give it to Quick Emulator. All right, let's run build and see where we're at, because it was giving errors. Why does it look like there's no prefix? What? Command not found. What? Do I have to do DOS to Unix again? I always hate when I don't put space in between, and then I'm like, where is the beginning? All right, assembler message. Can't create startup. No such file or directory. Oh, yeah. Duh. I gotta make reload. And man, I gotta change the editor. All right, let's do that, because I'm gonna have to keep doing DOS to Unix. Notepad ++ Windows. Change. It's the third thing. Carriage return line feed to line feed or whatever. No, I don't want to do that. I want to make it permanent. I feel like it's just right here. Show symbols. Show. I don't want to show it. I want to make what the default is. I thought I had the master link right away. Change line endings setting. Go to settings, preferences, language menu, tab settings, click default. Alright, settings. Okay, settings, preferences, language menu, tab settings. Okay. Really? I opened a menu. Really? I got like 32 gigs of RAM and like a really good processor and shit. Alright, and I already forgot what I was looking for. I think it was language. You think it would be in general and it'd be like, make all of it Linux-like. Or carriage returns. Language menu, tab settings. I want this, but I have to remember I did this because delimiter. Why is this? Everything has to be hard. How do I change the form? No. Why do Windows? Sorry, my screen's blinking. And Windows. No, I could repair the files. I just want to set with the. In this picture, is there default line endings? Default language. Menu edit, end of line conversion. This should convert. I don't want to convert. I want to make that the default. let me type something and see if it comes back. It doesn't make much sense. So it might like notice that what the line endings currently are, and then keep doing them that way. I'm not sure. So we wanted to. I forgot what I was gonna do. We wanted to. We have our source target, but we didn't have. Oh, we need to make directory. Make dir. I'll do -p, even though it's -p just means if there's multiple directories needed to be made, just make them all. Even though it's just one folder, it's not a big deal. So now I should have a target folder, right? Oh, it did make the target. Oh, did I save? Freaking carriage return line feeds back. So let's see what this edit thing looks like now. What? Huh? I'm already hitting this editor. This doesn't exist. Settings, preferences. There's language. Click on default. Change this tab size to 4. That's fine. Whatever. Uncheck the box replaced by space. If you're going to be using the program as a general editor. Here's what I want. Per line, you should not need to specify the line endings for existing files. To set Unix, you want tools, options, general, defaults. Tools. About to flip out on this program. Here's language. I mean, it's fucking bash. Not batch. Text direction, folding, it's all view related, edit. Am I like the newest or some old version? Like, why is this so hard? Hide, multi-line, vertical, reduce, lock, inactive tabs. None of this is talking about line endings. Editing. So this is just talking about the editor screen. New document. Oh, here it is. Man, that is so annoying. But now how do I... This already thinks that, and I'm going to switch it and then switch it back. Now let's see what's if... Alright, so now it's failing. I should just add EX on this, where one of them prints out every line that runs and the other one will bail out if it fails a line. Okay, so we got to all the way to the linker, and then it failed to find startup. Where's startup? Oh, I put it in the source directory, but startup is in the target directory. So is the other .o file for test. It just probably did them in a different order. So yeah, because the linker's in the source directory and the two object files are in target, and then it's going to spit out that guy and that guy. This is also in target. So let's give that a shot. I think that the line returns are working now. Cannot find startup.o. Wait, what? Let's see what's in there. Startup.o. Startup.o is in the target directory. Save, save, save. It says it can't find it. It's literally in the line. It says ./target/startup.o. ls target startup.o. Say what? Oh, I'm looking at the wrong line. No, that's the right line. Gotta be missing something here. What is it? Target dir startup.o. It expands out to be this. ls paste. Says there. Oh, probably because of the path I'm doing. The linker script says startup.o and maybe it's getting confused. That's annoying. So what I have to do for a quick test, I'm just going to see if that's true. I'm going to put it in the root directory and just do a move from target startup.o to here. And now we'll actually just run this last line by hand, or second to last line. Oh. Make those variables. So that worked. Yeah, it doesn't like that the path is on that. That seems annoying. I wonder if I can just have my let's look at the help, because I know I can do an include path for libraries. I know this is a simple thing, but I just can't think right now. What do I want? I want for where to search for my object files, but it wouldn't be my lib path. Our path? No. That's also libraries. Is non-object file considered a library? It's not a .a or a shared object. Let's just try it. Let's just make a target. Let's move it back. Can I just... Did we determine we can't just drag and drop? This is so lame. So let's move it back. Let's undo the change here. What we're going to try to do is dash I. Can't even think of what the include folder. Dash capital I for that's dynamic linker. Dash L is what I want. Capital L. I just want to see if that'll work. Let's try it. I don't know if it'll count like. And let's do a make a clean. Let's just clean each time for now. What is that? One alternative, but it's a little hackish though. It's not an include though. That would be for your headers and stuff. This isn't gonna work, but I could subshell it and run it from target. There has to be a way to specify this, or make the linker not care about it, to base name it or something. Why is because that dot slash won't work now. I have to just fix this for a second. I know I could use like the environment variable for present directory or whatever, or CWD or whatever the hell, but I'm just going to do it this way. Because I need full paths or it'll all get janked up. Alright. Cannot create directory. Slash target. What is it? Slash target. Why didn't PWD work? Why does it say project root Oh, because I didn't subshell. I did variable PWD. Right again. All right, so now we're getting somewhere. Multiple definitions of reset. Why does it think that? Man, my monitor keeps blinking like crazy. Multiple definitions of underscore reset. I hate the indentation on this. Let me just fix this a little bit. Yes, I use space or tabs. Come at me. Also, const here, and I'll explain all my syntax later. I like tabs mostly because people can set their own tab width. I put const here because if you have this, it reads a constant pointer to a constant character. Where if you do it on the other side, it's a pointer to a character that's const, and it doesn't read correctly. Because then you would get like const, then your type, then pointer, and then const. So you have a constant pointer to a bool, or say a character that's const, when it's really a constant pointer to a constant character. And then const always lands here, and const always lands here. So that it's always to the right and always to the right. So you read it right to left. The only time it's weird is when you have unsigned int, because then you're like constant pointer to a constant unsigned int, which breaks the right to left rule. All right, chat. So why are we getting multiple definitions? So we know the one definition's right here. Let's see. It says line 3 of the .s file. I'm not like specifying that twice, am I? I'm wondering if that needs to be a space, but we'll see in a second. Let's go back to the build. So what? This is in the linking step, yeah. LD, little LD. So we specify the linker script, these two .o's, and the output. So there's no reason test data. It's not gonna define that. Is it thinking that these are defining it twice? Maybe we don't need the global. I need to learn the assembly for it. This one I won't change the indentation because it probably matters. It's funny, now it's going to be like, warning, cannot find entry symbol reset. This. It either works or it doesn't work. Alright, so what is it saying in function underscore reset? Maybe I can get rid of the label. So linker warning, cannot find entry symbol reset. Defaulting to this address, which is the 10,000, but they added 10 to it. Wonder how many bytes these commands take. Probably, let me think, 10 hex, 16 bytes. If it was 16 bytes though, each instruction, I think that they're all the same size instructions. Does thumb do that? There's the thumb instruction set, but I thought ARM was all fixed instruction size. With 16 for 3 instructions. I mean, it said it did it, but This is not a good sign. If I put both of these in, it says that there's multiple definitions of reset. Let me learn about what .global does. So, arm as a I don't know if it would be the instruction set or a .s file, and like, let's search this for .global. And this is probably not like the proper instruction set. Accessing C global variables. What? It said .global. That has nothing to do with this. So is that what it's doing? It's exposing this as a global variable? I wonder if it needs to be this format. Let's try it just for the heck of it. Or these executable code follows, which I feel like you do need that. Then there's a label, and it says start is required by the linker. Main is our main program. Then there's like a branch to main, and then main does like a move, and then it does .end, which I don't know if that's needed. Cool makes it a global variable that the label is the actual entry point. But yeah, but why is it getting multiple definitions then? If I get rid of one of them. So it's saying startup.o in function underscore reset, multiple definitions of underscore reset. First defined on line 3 of, it's saying line 3, that doesn't even make any sense. This is line 3. This is intended to replace the existing code in the emulator where it normal bootloads Linux. Right, yeah, this is a startup code. But I'm confused why it's complaining about line 3. Moved it up one, which is really weird. But why 3? This like loads the top of the stack, and then calls C entry, which is in here, and then it'll jump back to here, I think. Yeah, but where 3 doesn't make any sense though. It's saying underscore reset is defined twice. I just do like that. No, it's not. That's gonna be a label has to be left justified. Let's try it. See what happens. Now it's just saying that colon is junk. If I just do this, will this work? See, and then it's throwing it at the end. It's linking it to the end. What if I just do that? It's back to the symbol name. Yeah, let's try it. Let's make a run script. Let's just try that binary and just see what happens to it. Alright, so why wouldn't you give me focus? Like, I just created a file. You think that it would have focus? No, let's not give you focus. Let's make sure that the quick emulator is on here. How is it not on here? Maybe it doesn't start with quick emulator. We put that, I think we put that last time in our Vagrant file. Let me make sure this is installed. Change the name and the .global here, and then use the map to find the reset. I don't know how, I must have destroyed it at some point. So you're saying in change the name and the .global, and then use the map to find the reset. Like, it's going to reference this global, and this global is defined right here. Change the name and .global here, and then use the map to find the reset. Let me just see something. We have his other example open. We'll definitely come back to this in a minute. So I like how he has like the actual reset handler. So he references startup the interrupt vector, which is this section, is what he's going to put as executable code right here at 0. But in this linker script, It's referenced here. Where's X used? Alright, well let's try to run the output. So we were gonna make a run script. Normally I would chmod it, but let's just do it anyway. U plus X run. Test.bin, what did I call it? Oh, it's probably because I have it in a target directory. And you know what I'm going to do? I'm going to make another file. I'm going to do son of a... I can't even rename here? Oh, wow, this is crap. I like to share that so that all those defines are there. Maybe I should spell whatever. Shorthand's fine. Hey, it says "Hello World." Now all this stupid audio stuff is there, but I bet you when he wrote this, they didn't have a lot of that support probably. So it said "Hello World." Better than we did last time, chat. Let's read some more of what he said. These commands create a ELF program and a bin binary image that I can use with the Quick Emulator for the ARM system. In Debian, the Quick Emulator can be installed running that as root, and the installation of that program in Ubuntu, whatever you want to call it. This program is not present in that package. Instead, you go to the extras, which I didn't. That's not what I use, but I still have it. Whatever. For this reason, I got the other thing. Whatever. And then you run it with that, and we already looked at this last time. So it says that the machine is the versatile PB, which is important. That the RAM memory is 128 meg. I'm guessing that's megabyte. It says no graphic, so it's a headless. And then the kernel is the binary image. And then he's just going to re-say what I just said. And then what it says is that the -M specifies the emulated system. You can also do the -C for the which processor, or was it MCU? I forget. And then it should output "Hello World" in the terminal and runs indefinitely. To quit it, you can do Control A and then X. Let me just make sure I can do that because last time. Okay. Last time it crashed and I lost everything, and then I just had to end stream because I was just like so mad that I lost it all. Now I'm sharing it across to my native one. So it actually worked when I put that error in, but it's still complaining when I had it like this. It worked, but yeah, the symbol's not actually exposed, but it doesn't compile when it has multiple definitions. So there's something we're doing wrong there. Now I'm wondering if we need a dot text. I want to learn how to make some of these assembly, so maybe we'll dive into that because I just need to know all this. Like assembler, like link direct or whatever it is. Those aren't that hard. Branch literal or branch to an address. This is like calling a function. This is copying this variable into this register. I'm probably getting that a little wrong, but it's the gist. So next, they add in the symbols to start up the GDB server in the emulator, and then you can connect to it. So let's just do it really quick. Do I have the ARM GDB? I'm guessing it came with... It did. Cool. So I can follow his commands. So you need these two. One of them says to like expose, like to have to. One of them says to stop at the first instruction so it doesn't start executing, so we can step through it. And the other one says to expose the GDB server. And we compiled with symbols, so we should be able to debug. For now, I'm just gonna comment this guy out, and let me just build again, just to prove I can still build again. Cool. I'm actually surprised it didn't have a bigger problem because this was at the wrong address. Because when I run it, it says hello world at the end. I wonder if it ran like 16 zeros that did nothing, no ops, and then it ran the startup code. If I put this back in, I get a compilation error, right? I get a linker error. Startup.o in the function has multiple definitions of underscore reset. Change the name and the .global, and then use the map to find reset. It's also expecting in startup.o a .text section. I wonder if I need like a... I saw that in some of the other... What is this? What would this do? What if I do this? I'm back to where we were. Just trying to reference it right here. Huh? This is like almost like like a declaration of this, and then here's the limbo, like the definition almost. For right now, I'm just gonna comment this out, and I'll get rid of this because I don't know if that's correct. I get a warning, but we know it runs. So let's add to our run script for now and debug little s and big S. So just for so little s, so stop it when you start up, and big S, or no, big S is do not start the CPU at startup. So it just says to like stop right away, and little s says start a GDB server at TCP port 1234. So that's why in his example, he's gonna start a GDB session and then say I have a remote target at localhost 1234, and then he's gonna point to the ELF file, so which has all the symbols in it, so he can like your client can know about all that. All right, so yeah, let's just do that. Let's just run. I'm gonna want to run that in the background though. I wonder if that'll automatically do that. Let me see. Now I gotta get a second shell. Should I just run that in a sub shell? Yeah, we'll just open a new terminal. Put this on the bottom right. Stream. SSH. It's not that hard. All right. So /vagrant. What? Yeah, I said CD/vagrant. Forgot the CD. So I'm gonna run GDB server, which I could do that from anywhere really. GDB. It's gonna give me a prompt. Now I'm gonna follow his instructions. So let me actually take these. I'm gonna throw them on the bottom right corner. No, I don't want to. No. I thought I can get fancy with it. Get fancy with it. So we want to set the target. I think we just say T, because like GDB is like weird and it'll try its best to like. But whatever. We're just gonna do localhost 1234. So it tried to connect to it. What did it say? When no executable has been specified. Well, yeah, that's what I'm about to do. Try to use the file command. Yeah, file and we actually want target test.elf. And notice we don't do the bin because it has to have all that other stuff in it. This program is being debugged already. Alright, so now I could say run with R, but yeah, I think I could reset it. So, or is it resume? Continue. Yeah, it said hello world, and then I can do it's like a reset. Oh, it's running forever. GDB has a way to break though. Man, what are the GDB shortcuts? I haven't done this in forever. GDB keyboard. Yeah, cheat sheet. Perfect. I thought it was run. Run the program to be debugged. Kill, break, and somewhere you want to break. What is the keyboard shortcut for? It's not Control C, I don't think. Okay. Yeah, I got. Okay, cool. I think there's a way to say like restart the program.
Come on, screen. Xfinish. There's not like a reset? What the heck? Breakpoints, watch points, conditions, where, running. Oh, it doesn't support run. How do I get into the I mean, I know I can just do this and this. It's a long help menu. Holy crap. System reset. System reset. Reset the system. Why I want to do that? Maybe I think you should. Alright, I terminated it. Did my GDB lose this? So let me run again. I probably need to do so I want to do next and step through. That was what I needed this for. It's not running yet, but I want it to break. If I say run, it's going to run to the end or continue. Program is not being run. Oh. I could set a breakpoint. I could do breakpoint, and then in where I could set a file name variable, and I could do that. So I could do breakpoint. Where is it? Oh, sorry, break. And the where I want is the file name and variable. You type an address or register. So the file name we want is startup. Do I need the .s? I think so. And we want to do that at reset. Function is not defined. I'm going to exit out of this for. I want to do. What is it? Object dump? Of target. So here's the startup code. And memory address 10,000 hex. really weird that these are the same. Should be startup.o. Startup.o reset. Startup. What's it called? Test.elf. Want to break the file name, which should be startup. I think it's going to be .o, and then underscore reset. I think with double quotes, colons. This is not defined. Probably because of this global not being here. What does his example actually say? Does he have more steps to step through it? Continue runs it. Yeah. I know it's possible, but I'm sucking at it right now. I want to single step it, but it won't let me start. It's like it's not running. Let's step into the first command. Go back to this cheat sheet. You know what? I could just do. There's 2 locations, it says, and then it kind of goes back to that linker error. But it went to the one at 10,000 hex. So now if I do continue, I should break at that. Well, there's the instruction we expect right here. So then if we do, is it next step? Is it step? Yeah, now we're here. So now we're going to step into here. Coolio. Then we're going to go up here. Now it's going to go into the while loop. It's going to write that to it. Happens instantly because it's emulated. Does it again. And let's step out of cheat sheet for the win. Alright, where's step? And the other next finish continue. There's step. How do you step out? Chat, am I like, what? It feels like that would be fairly generic. Like, go to the next return from a branch. Seriously? Oh, is it next? No. Oh, okay. So step will step in, where next will step over. There's no step out. I'll try finish, but it's probably not going to work. Help. Running. So step program. Reverse. Detach. Jump. Continue program being debugged at specified line. Oh, no, you don't want to do that. Start the program. Signal. Run. Really? It doesn't have the notion, like it can't know that it's returning from a subroutine call. I guess it doesn't because it's just, well, no, because it knows about the symbols and everything. I mean, I could do, wonder if I could put a breakpoint out a few lines down. So that's the current line I'm at. Yeah, I know you use info locals a lot. So, how's there no locals? Oh, that's a stack variable. Maybe that's why. You can do info. Just kind of looking around at different things. So I know in ARM they'll use the registers for stack for arguments. Stack pointer. So that's because we did 10,000 plus 1,000 here for where the top of our stack is. So it's grown by 90 bytes. Program counter is at 10,024. Is this the return address? Let me think. Because that would be right here. Wonder what. It's not that. See, we have HEL. I'm just gonna step enough to because I do want to see if that's the case. You see each character coming out at the bottom. L D exclamation point, new line. Print. It wasn't address, it was info? No. No, it was info. What was it? How did I see where I was currently at? Not address. The frame. I should have looked at that while I was in the function call. Program. That's your call stack. Oh. Yeah, for some reason it thinks it has another one at reset at there. But we're currently in here. How did I see that before? I did it before. I know I did it before. It's probably line. Yeah, that's what I wanted. Yeah, so was this the return address before? No. That would have been it. I wanted to see if the return address that we saw in the register 0, if it was going to return back to here. But we should know that the next step. So if we step again, we go to the beat right there, and then that's going to sit there branching to itself forever. I wonder if we could just for like if I could do that and just make it endlessly print. So let's rebuild And let's run. And I should be able to just say continue. Probably have to reattach. So target target remote local host 1234. Reconnect to them. Oh, there's no bin. Oh, hey, no, it said it compiled. Yeah, it timed out. Run. Okay, now it's running. Okay, connected. Alright, so now I want to just do continue. And let's just see. Why is it terminate? Oh, because we have the -S, it's stopping each time when it gets to the top. But that's cool. We have it so that it like resets itself at the end. So we learned a little bit about that, how the reset works. And we know our code's running there. It sets the stack pointer, calls in the entry point. Whenever entry returns, it'll go back to the beginning and do that again. I think that's where we're going to call it today. Let me switch off of this. So we're having like a hell of a time just trying to do it ourselves with the Intel machine and trying to use the Cortex M4, and then we were going to go to M3. I was like, today we're going to start over, go back to what somebody says works, even though it was 10 years old. We saw that there was ALSA stuff and things that we could probably put flags to say, similar to no graphics saying no audio. But we got stuff to work. Everything's there. Next time we're going to try to go to a different machine and kind of understand this. And now that I know about the GitHub for QEmulator that has all of the board layouts and configuration and the bring up of each machine, I could probably just go in there and find addresses for things and understand how to link. We didn't really understand the 0 address versus the 10,000 hex, or I don't yet. How the entry point is going to go to there. They said their system's just going to do that, but I didn't see that anywhere in the board code. But maybe it's in the underlying system. I don't know. We'll dive into that more next time. But at least we're successful today. Everything went smoothly. So next time, hopefully we can take this. So this week, because I didn't do anything last week, I'm doing 3 this week. I'm going to try to do 3 anytime I can. But I'm planning Friday. I might do Thursday instead. But I put Friday up on the schedule. And then I'll do Sunday as well, even though it's Mother's Day. So I might switch that to Saturday, but probably just for now, just expect Friday and Sunday. And if anybody has any questions, hit me up on Twitter. You can see it on my Twitter handle there, and leave some messages to my direct messages on YouTube are fine. And yeah, I'm excited now because we got this working and we got debugging and we set through all the code and everything, so that was really good. Alright, I'm going to leave it there. Till next time, keep hacking in your basements, and it's going to be fun. We're going to get this working on some hardware next and get it going with a Cortex M4. So talk to you guys next time. Keep hacking.